Hi, folks. So I just want to make this brief video reviewing some of the more challenging problems, some common challenging problems from this unit, which is chapters 4 through 7. More specifically, chapter 4 was broken into two parts, A and B. Then we had chapter 6. We skipped over chapter 5. And on this test, we're just going to be covering chapter 7, part A. So that's some of the homework problems that I'm going over. So chapter 4A was all about nomenclature. And so I'm just going to go over a couple of nomenclature problems, particularly with ionic compounds. So 4A number 56, write the chemical formula for ammonium phosphide. So the first thing you need to do when you're writing chemical formulas is make sure you know first identify that this is an ionic compound. Ammonium is a polyatomic ion. It's a tricky one because it sounds like kind of sounds like aluminum, or it sounds like it should be an element on the periodic table, but it is not. It's a polyatomic ion, meaning that it's an ion that has many atoms in it. Phosphide is the ion of phosphorus. And when we go to the periodic table and we look up phosphorus, all right, it's over here on the right side, and it is in the group or column number 15, also known as 5A. All right, it has 5 valence electrons, which means that it needs to gain 3 more in order to have a full valence shell and be like a noble gas. So if it gains 3 electrons, and electrons are negatively charged, then that phosphide ion has a 3- charge. So when we are writing the chemical formula for this, we need those charges to cancel out. The ammonium has a 1+ charge, the phosphide has a 3- charge. So in order to have a neutral overall 0 charge, we're going to need 3 of these ammonium ions. So in a chemical formula, when we indicate that we have more than one of an atom, we use the subscript. And since we want this subscript to apply to the whole ammonium polyatomic ion, we use parentheses to group it all together, and then we put our 3 outside of it, and then we just have a single phosphide ion. So the chemical formula for ammonium phosphide is NH4,3P. Okay, now I just lost my train of thought. Oh, well, I guess I'll come back to it. 4A, number 70. Write the chemical formula for iron 3 sulfate heptahydrate. All right, so that's kind of a mouthful. So let's start with writing out sort of the ions, the components here. So first I'm going to say iron is a metal and sulfate is a polyatomic ion. So when I have a metal and it's made up of nonmetals, sulfate is SO4, 2-. Okay, and iron is a metal from the periodic table, so this is an ionic compound, clearly. Now, iron is in the group of transition metals on the periodic table. Transition metals can make a variety of ions, so we can't necessarily tell what the charge is just by looking at the periodic table like we were able to do for phosphorus. The nice thing is, though, this Roman numeral here basically tells us what the charge is. So an iron 2 ion has a 2+ charge. So when we combine these together, the charges are going to cancel out. They both have, so 2+ and 2- will add together to make 0. So in this case, our ionic compound here is just FeSO4. No need for parentheses when you just have one of the polyatomic ion. But then let's not forget about the heptahydrate. So that means that this is an ionic compound that's bound to some water molecules. And the prefix hepta means 7, and hydrate means water. So it's iron sulfate bound to 7 water molecules. Iron 2 sulfate heptahydrate. 4A number 96 from the homework, predict the chemical formula for the ionic compound formed by calcium ion and chlorate ion. Or is it chlorite? I can't remember. Okay, so calcium has a 2+ charge, and the chlorite or chlorate ion has a -1 charge. So we're going to need 2 of these guys so that we can cancel out the 2 positive charges of the calcium. So we get calcium. We always write the positively charged ion, the cation, first in all of these problems. You'll notice that. And the negatively charged anion second. Since it's a polyatomic ion and we have more than one, we need to put it in parentheses with a subscript of 2. Notice that when we have our ionic compound formula, there are no charges. The ionic compound is neutral. So those charges are just there when we write out the ions separately, but when we write out the compound formula, there should be no charges present. It's a common mistake that I see. All right, next page. Now for some stuff from the second half of chapter 4, which is all about Lewis structures and a little bit about Vesper, the sort of 3D shape of molecules. So I like this problem here. So it gives you a skeletal structure, and I'm going to draw out the skeletal structure of SO2, Cl2, and it doesn't actually matter so much where I put those O's and Cl's. And then it says, starting from this structure, complete the Lewis structure that follows the octet rule on all atoms. So the first thing I'm going to want to see your work to calculate electrons. So how many valence electrons should we be distributing? So S, sulfur, is in group 6 of the periodic table. It has 6 valence electrons. Oxygen is also in that group, and there's 2 of them, so 2 times 6. And chlorine is in group 7, so it has 7 valence electrons. So we add up all the valence electrons and we get 32 valence electrons. I'm going to want to see that work in order for you to get full credit on a problem like this on a test. All right, so now you're going to want to distribute those 32 electrons, starting with the outermost atoms. So I'm going to do 6 here, 6 here, 3 pairs of 2, and see how many I have. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and then the bonds, 26, 28, 30, 32. So check, I've accounted for all 32 electrons, and now I'm going to check that everybody has an octet, and the oxygens all have 8 electrons around them, the chlorines have 8 electrons, and the sulfur has 8 electrons. Check. So this would be the correct answer for this question. If you were to Google this molecule, if you were to Google SO2Cl2, you will see that this is not the actual Lewis structure of this molecule. And that's because sulfur is a rule breaker. It violates the octet rule, and it can have more than an octet of electrons around it. And so in reality, it actually looks something like this. This is a cautionary tale not to use Google on the test. Part of how I am going to assess you is by asking you questions that are not Googleable, that Google will give you the wrong answer for, because I want to see that you understand how to apply rules. And, later in more advanced chemistry classes, you can learn more about those rule violators. But it is always good to have in the back of your mind and know that there are exceptions to the rules. All these rules I teach you, there are exceptions. Nothing chemistry perfectly follows all of the rules, but it's important to sort of master and understand the rules before you get into learning about the exceptions. So I like that example there. I don't have this one in this review here, but a good one to review when you're practicing for the test. 4B number 37. It's one of those multi-part questions, and it asks you everything. It gives you information about electron configuration. So it's like the electron configuration of a molecule is such and such and such. So how would it form? Draw the Lewis structure if it bonded with this molecule, and what would the three-dimensional shape be? Is it tetrahedral or trigonal planar? So it's really a good comprehensive question. And I often like those kinds of questions on tests where it kind of addresses multiple things at a time. or really on a final. That's usually the kind of question I ask. I might not do that on this test, but still, it allows you to practice a lot of things in one problem. Next, Chapter 6 stuff. So Chapter 6 is a lot of math, doing a lot of conversions and a lot of dimensional analysis, going from moles to grams, or doing concentration calculations. So this one, number 3, this one it says determine the mass in grams of 3.0 times 10 to the 21 atoms of arsenic. And it's so kind to give us the molar mass of arsenic, which we could have found ourselves on the periodic table. And on a test, I would not be so generous to give you that information. I'd want you to find it yourself. So determine the mass in grams. So in this problem, we want to use this sort of guide pathway. So we go from atoms to moles to grams. And we can go in the reverse direction as well if we need to in a problem. In order to go from moles to grams, that's where we use the molar mass. And in order to go from moles to atoms or atoms to moles, that's where we use Avogadro's number, 6.02 times 10 to the 23rd. So in this case, we always want to start with the number we are given, the amount of something that we're given. I like to pretend like somebody just handed me something. In this case, they handed me 3 times 10 to the 21 atoms of arsenic. And so that's the number I'm going to start with. And then I'm going to use dimensional analysis to ultimately find mass in grams. So first I need to cancel out atoms and turn them into moles. And then I need to cancel out moles and turn them into grams. And so to go from atoms to moles, 1 mole is 6.022 times 10 to the 23rd atoms. And to go from moles to grams, 1 mole is, we can look up on the periodic table or conveniently in this problem, 74.92 grams. And then I just type this in my calculator. Let's open my calculator. 3EE21 divided by 6.022 EE23 times 74.92 equals 0.373. I have 3 significant figures in the number I'm given, those atoms, and I want to make sure I have my units, which are grams. So don't forget sig figs and units. They are small point deductions on the test, but they can add up. I usually try to have a reminder, don't forget sig figs and units. All right, so there's a lot of different ways that these, conversion questions can be asked. You could be given atoms of something and asked for moles. You could be given moles and asked for grams, or grams and asked for atoms. So there's so many different permutations, but using this sort of pathway up here as your map will always help you figure out how to set up the equation. And always start with what you are given, what is handed to you. And usually that number is going to be a number that is has a single unit, not like the molar mass, which is grams per mole. All right, number 27, chapter 6, number 27. How many moles of CH3OH, that's methanol, are in 50 milliliters of a 0.4 molar methanol, it should say methanol solution, of 0.4 molar methanol. So molarity is a concentration. Concentrations apply to solutions. So what we have here, another way to write this molarity, molarity is in units of moles per liter. Okay, and so if we write it like that, then we can see more clearly that this molarity is potentially a conversion factor. And so the number that we are actually given, the amount we are given in this problem, is the 50 milliliters. So we're going to start with 50 milliliters. And we're going to convert that to moles. That's what we want to find using that conversion factor of the molarity, 0.400 moles per liter. Now the problem I have here is that my volume units don't match. Milliliters and liters don't cancel out. So I could multiply by another conversion factor to convert milliliters to liters. What I'm going to do is just kind of do it in a step here. I'm going to say that this liter is the same thing as 1,000 milliliters. And now my units match, so they can cross out. Okay. Another way, you could have converted that 50 milliliters to liters if you wanted. There's, several right ways to do this. Just make sure that those units match so that they cancel out, and you end up with 50 divided by 1,000 times 0.4, 0.02. Now technically these two numbers have three significant figures, so my answer should have three significant figures, 0.0200 moles. Or you could also write that as 2.00 times 10 to the negative 2 moles. Either one is acceptable. Okay, number 33. If 50 grams of methanol, and it's kind enough to give us the molar mass in the problem, are added to a 500 milliliter volumetric flask, and water is added to fill the flask, what is the concentration of methanol in the resulting solution? So with long word problems, I have a hard time processing. I like to draw pictures. I'm very visual. So I'm just going to draw myself a picture. I'm not an artist. This is supposed to be my volumetric flask. It has a volume of 500 milliliters. And what I put in it is 50 grams of methanol. Okay, so I have 500 milliliters, and then I fill it with water. So I have a solution that contains 50 grams of methanol. And I want to know, what is the concentration? Now, in Chem 101, the units are in the answer area. On a test, I would need to tell you what units I want it in, but generally concentration, you're looking for units of molarity. So we're looking for molarity of the resulting solution. Okay, so the first thing I'm going to do here, well, the first thing I did was draw my picture, but the next thing I'm going to do is I'm going to remind myself on paper that molarity is moles per liter. So it's moles per volume. Do I have those things? I need to know how many moles of the methanol I have and what volume of the solution in order to solve for molarity. Well, I don't have moles, but I do have mass, and I can multiply that by the molar mass in order to get moles, which I can then plug in on top. And I don't have liters, but I do have volume in milliliters, which I can easily convert to liters by dividing by 1,000. All right, and then I can plug that in right there. So I'm going to go ahead and plug in my 0.500 liters on bottom. I'm going to calculate moles over here on the side. So 50 grams of methanol. The molar mass of methanol, it tells us so conveniently, but we could just calculate it ourselves using the periodic table. Oops, and I don't want to put that number on top. Pixel eraser, this is new. I want to put that number on the bottom because I want my grams on bottom so they will cancel out. 32.04, 1 mole, and that is 50 divided by 32.04, 1.56, and I'm just going to carry this out a little extra because I'm not done with my calculations yet. I don't want to round to 3 sig figs just yet. Plug that in here and divide by 0.5 to get a molarity of 3.12. Now is where I wanted to round to significant figures, 3 of them. 3 sig figs. There's 3 sig figs here and 4 sig figs here. I'm going to use the lesser of the two. So my answer is 3.12 molar. So drawing pictures can be really helpful to help you map out what the question's asking, but also writing out any formulas you can, especially for concentrations. Remembering that molarity is a unit, but it's really the units of molarity is moles per liter. And then this last page here, chapter 6, number 40. This one I have in bold because a lot of people struggled with this one, and there's a reason for that. So it says, what is the concentration in percent molarity by volume of a 0.315 molar aqueous solution of acetone? And it gives us the molar mass of this acetone. So I'm going to start here by writing out some formulas. So percent mass by volume, that is going to be the mass in grams of our acetone divided by the volume in milliliters of our solution. Okay, and we also are given a molarity. So I'm going to remind myself that molarity is really moles per liter. It's moles of solute, in this case that's acetone, per liter of solution. And we also are given a molar mass. And molar mass is grams per mole. Okay, so now I like to check off the things that we have and the things that we're looking for, so I can start figuring out where I'm going to start this problem. So we want to know what is the concentration in percent mass by volume. So that's what we're trying to find. We're given a molarity, so we've got that, and we are given a molar mass. So we've got that. So we don't have enough information to solve anything just yet. And this is a case where we actually can sort of make up a piece of starting information. And that's because we're converting from percent concentration to molarity. So if we're converting from one unit of concentration to another, the concentration isn't going to change. If I have a glass of acetone, and I want to know what is the percent of that acetone and what is the molarity of the acetone, that concentration is not changing. It's staying the same. And so because of that, it doesn't matter how much acetone we have. But in order to solve this problem, we need more information. So we need to pick an amount of acetone to be working with. The easiest thing to do is to pick a volume. So we can do this when we are converting between one concentration unit and another. We often need to do this when we're converting between concentration units. So when we're converting between concentration units, pick a volume. The easiest volume to pick, I think, is 1 liter. So I'm just going to add to this problem that we have a volume of 1 liter. So if that's true, then we know this volume and we know this volume. 1 liter is 1,000 milliliters. So we know those. Now we have enough information to solve one of these variables, this one right here, the moles of acetone. So that's the one I'm going to do first. So if we have 1 liter of solution, and we multiply that by the molarity of 0.315 moles per liter, all right, then we get 0.315 moles of acetone. Cool, well guess what? Moles goes right here. Now I know moles, which means I have enough information to figure out how many grams we have. So the sort of second thing I'm doing here is multiplying that by our molar mass, 58.08 grams per mole. 0.315 times 58.08 is 18.295 grams. All right, and guess what? grams is needed over here in order to solve for the percent mass volume. So now I have the two pieces of information that I need to solve what I'm actually asked for in the problem. So then the third step here is to take the grams, and divide by the volume, 1,000 milliliters. And I always forget to write this in the formula, but we will need to multiply it by 100 to turn it into a percentage. So divided by 1,000 times 100 is 1.8, and now I'm going to round it to our 3 sig figs because this is my final answer, 1.83%. Okay, so the key here that you won't be able to start this problem unless you pick an amount. And the reason you can pick an amount to start with is because it doesn't matter what the amount is, the concentration is not changing. Okay, the concentration is independent of the amount of liquid you have. And since you're just going from one concentration to another, you can do that. All right, number 43. What is the mass of acetone in a 1.77 molar solution of acetone? So we have, what is the mass percent of acetone? That's a weird way to say it. I would say, what is the percent mass? So we want to know percent mass of acetone in a 1.77 molar solution. Or in other words, there's 1.77 moles per liter of solution. We know that's the molarity. All right, we know the molar mass is 58.08 grams per mole. And we know that the density is 0.971 grams per milliliter. And we have this solution. It's made up of acetone and water. They're mixed together, but I'm going to kind of draw them separately. So we want to know what is the mass percent of the acetone Okay, so essentially, this is kind of similar. So it's giving us the molarity, and we want to know what the percentage is. So we're going to start by figuring out what it is we have, what it is we need. So the mass percent is going to be grams of acetone over grams of solution. Okay, and this is where things can get a little bit tricky because the grams of the solution is the grams of the acetone plus the grams of the water. So we're going to need to know the mass of both of those things. So, in this problem, we need to start with what we have, but similar to the previous problem, we don't have anything. It hasn't given us an amount of something. It gave us information about that solution. It tells us it's made of acetone and water. It tells us the molarity. It tells us the molar mass of acetone, and it tells us the density, but it doesn't tell us how much we have. So again, we need to pick a volume. All right. So for ease, again, let's just say 1 liter. All right, so if we have 1 liter of this, let's start with that 1 liter, 1.00 liters. And let's figure out, we can use the density to figure out the mass of the solution. All right, so since the density is in milliliters, I'm going to convert that liter into milliliters. So I'm going to say we have 1,000 milliliters. And if I multiply that by the density, 0.971 grams per milliliter, that gives me 971 grams of solution. All right, so I have this piece of information now right there. Now I need to figure out how many grams of acetone that I have. Okay, so if I have I'm going to need to use the molarity and the molar mass for this. So if I have 1 liter of this solution, and I know that the concentration is 1.77 molar, meaning there's 1.77 moles of acetone per liter, all right? And so now I know how many moles of acetone there are. I can figure out how many grams of acetone there are using the molar mass. So my moles will cancel out, and I'll figure out how many grams of acetone there are. So using my calculator, 1.77 times 58.08 equals 102, oops, 102.8. I lost my train of thought here. How many sig figs do I want? I want 3 sig figs. Well, not yet. Okay, so now this is grams of acetone. All right, so now I can do the percent mass. It's going to be the grams of acetone, 102.8 grams of acetone, over the total mass of the solution, which is 971 grams, times 100%, divided by 971, is going to be 10.6. 10.6%. Ta-da! So writing out the things that you have and then making sure you realize when you need to pick a volume to start with. It's sort of another way to think of it is if you're not given a starting amount of something, then oftentimes you need to pick that starting amount. But the reason we can do it is because when we're converting between concentration units, percent versus molarity, the volume, it doesn't matter what volume we use because the concentration is not changing. We can use any volume we want. You don't have to use 1 liter. You can use whatever, 2.86 liters if you want. I don't care. It just makes the math easier to use the number 1. And it looks like that's where I've stopped in this review. I don't have any questions from chapter 7, but you guys can message me as needed. The end.